Good morning, students. So, how are you all? Children, as we know that chapter 3rd, Interior of the Earth, is going on, and in this chapter, we already discussed about the sources of information like direct and indirect sources. And apart from this, we already discussed about the earthquake. And today, we will discuss about the structure of the earth and volcanoes. So here uh, we have three layers in the interior of the earth: crust, mantle and core, and we will understand about these layers with the help of the diagram. Okay, so let's start with the first layer, which is the crust. So it is the outermost solid part of the earth. Now you can see in this picture the first layer is crust, and the thickness of this layer is 0 to 100 kilometers, and which is called lithosphere. Okay, so it is brittle in nature, and the thickness of the crust varies under the oceanic and the continental areas. And oceanic crust is thinner as compared to the continental crust. The mean thickness of oceanic crust, mean thickness, we are talking about the mean thickness. So oceanic crust is about 5 kilometer, whereas that of the continental is around 30 kilometer. So the continental crust is thicker in the areas of major mountain systems, and it is as much as 70 kilometer thick in Himalayan region. So it is made up of heavier rocks having density of 3 gram per centimeter cube. And this type of rock found in the oceanic crust is like basalt, and the mean density of material in oceanic crust is 2.7 gram per centimeter cube. So these are some measures of the crust, and in the diagram you can see the thickness of the crust is about, if we talk about the kilometers, it is about 0 to 100 kilometers, okay, which is called lithosphere. And come to the next layer, which is mantle. So the portion of the interior beyond the crust is called the mantle, or we can say the middle part of the crust or the core is called mantle layer. So the mantle extends from Moho's discontinuity to a depth of 2900 kilometers, and the upper portion of the mantle is called asthenosphere. So we can divide it into two parts, the upper layer or the lower layer. So the upper layer is called asthenosphere, and the word astheno means weak. It means upper layer is weak layer, and it is considered to be extending up to 400 kilometers. So it is the main source of magma that finds its way to the surface during volcanic eruptions. So it has a density higher than the crust. It is about 3.4 gram per centimeter cube. So the crust and the uppermost part of the mantle are called lithosphere. So its thickness ranges from 10 to 200 kilometers. So the lower mantle extends beyond the asthenosphere, and it is in solid state. Clear? Now come to the next layer, which is the core. So the earthquake wave velocities helped in understanding the existence of the core of the earth. We already discussed about in our earthquake topic. So the core mantle boundary is located at the depth of the 2900 kilometers. So the outer core is in liquid state while the inner core is in solid state. So we can divide this core part is also in two parts, liquid and solid. So the density of material at the mantle core boundary is around 5 gram per centimeter cube, and at the center of the earth at 6300 kilometer, the density value is around 13 gram per centimeter cube. So the core is made up of very heavy materials, mostly constituted by nickel and iron, and it is sometimes referred to as the knife layer. नाइफ बिकॉज क्योंकि निकल और आयरन का जो सिंबल है, निकल इज Ni and the symbol of iron is Fe. So we can combine these two and which is called knife layer. Okay, clear. So the next topic is volcanoes. So what is volcano, or what do you mean by the volcano? No. Okay. So volcano is a place where gases, ashes, or molten rock material or the lava escape to the ground. So a volcano is called an active volcano if the materials mentioned are being released or have been released out in the recent past. Clear? So the layer below the solid crust is mantle, and it has higher density than that of the crust. And the mantle contains a weaker zone called asthenosphere. We already discussed this. It is from this that the molten rock materials find their way to the surface. The material in the upper mantle portion is called magma. Once it starts moving towards the crust or it reaches the surface, it is referred to as a lava. So don't be confused in these two words, magma and lava. Okay, clear? So the material that reaches the ground includes lava flows in form of pyroclastic debris, volcanic bombs, ash and dust and gases such as nitrogen compounds, sulfur compounds, and a minor amount of chlorine also, hydrogen and argon. सो वी तो इस तरह से जो है वॉल्केनो का जो है फॉर्मेशन होता है, किस तरह से जो मैग्मा है या लावा है, इट कम्स आउट फ्रॉम द इनर पार्ट ऑफ द अर्थ and forms volcanoes. So volcanoes we can classify it on the basis of natural or the nature of the eruption and the form developed at the surface. So we can divide it into 4-5 parts. First is shield volcanoes and the composite volcanoes, caldera, flood blast volcanoes, and the mid-ocean ridge volcanoes. So we will discuss these 5 types of volcanoes, and let's start with the shield volcanoes. What are these? So bearing the basalt flows, actually volcanoes जो हैं 3-4-5 टाइप्स के तो होते हैं, बट किस तरह से इनका जो फॉर्मेशन है, किस तरह से इनका जो ब्लास्ट होता है इनके अंदर, उसके अकॉर्डिंग हमको डिवाइड करते हैं. ठीक है, तो इरप्शन के अकॉर्डिंग जो मैंने आपको पहले बताया. So bearing the basalt flows, the shield volcanoes are the largest of all the volcanoes on the earth. Now you can see the picture also, this type of volcanoes. So this is a shield volcano, and the Hawaii volcanoes are the most famous examples of these. तो जो Hawaii is an island जहाँ पे बहुत इतने सारे इस टाइप के जो volcanoes जो पाए जाते हैं, you can see. So these volcanoes are mostly made up of basalt, a type of lava that is very fluid when erupted. So for this reason, these volcanoes are not steep. They become explosive if somehow water gets into the vent. Otherwise, they are characterized by low explosivity. The upcoming lava moves in the form of a fountain and throws out the cone at the top of the vent and develops into a cinder cone. Clear? Now come to the next, which is composite volcanoes. And now you can see this is a picture of composite volcanoes, and these volcanoes are characterized by eruption of cooler and more viscous lavas than basalt. So these volcanoes often result in explosive eruptions, and along with lava, large quantities of pyroclastic materials and ashes find their way to the ground. So this material accumulates in the vicinity of the vent openings and leading to formation of layers, and this makes the mounds appear as composite volcanoes. Clear? Okay, so next is caldera. Now you can see this is a picture of caldera volcano after the explosion. बाद में क्या है कि जैसे अगर गैप आ जाता तो वाटर जो होता है उसमें फिल बन जाता है और एक टाइप की लेक या पॉन्ड बन जाता है. So these are the most explosive of the Earth's volcanoes, and they are usually so explosive that when they erupt, they tend to collapse and themselves rather than building any tall structure, and the collapse depressions are called calderas. So their explosiveness indicates that the magma chamber supplying the lava is not only huge, but it is also in close vicinity. Now come to the next type of volcano, which is flood basalt provinces. So these volcanoes output highly fluid lava that flows for long distances, and some part of the world are covered by thousands of square kilometers of thick basalt lava flows, and they can be a series of flows, with some flows attaining thickness of more than 50 meter, and individual flows may extend for hundreds of kilometers. If you can take an example of Deccan Trap from India, so presently covering most of the Maharashtra plateau are as much larger flood basalt province, and it is believed that initially the trap formation covered a much larger area than the present. So this is about the flood basalt provinces. Now come to the next. This is a mid-ocean ridge volcanoes. Mid-ocean ridge volcanoes, ये underground water होते हैं. So these volcanoes occur in the oceanic areas, and there is a system of mid-ocean ridges more than 70,000 kilometers long that stretches through all the ocean basins. The central portion of this ridge experiences frequent eruptions, and we will discuss in our जो आने वाले चैप्टर हैं, नेक्स्ट चैप्टर्स हैं, उसमें हम इसको और क्लियरली डिस्कस करेंगे, जिसमें हम मिड ओशन रिजेस के बारे में बात करने वाले हैं. ओके, सो कम टू द नेक्स्ट टॉपिक, which is volcanic landforms, and in this we will discuss about the intrusive forms only. So in volcanic landforms, these are some forms: batholiths, laccoliths, lapolith, phacolith, and sills, dikes. So we'll discuss these all. So the lava that released during volcanic eruption on cooling develops into igneous rocks, and the cooling may take place either on reaching the surface or also while the lava is still in the crustal portion. So depending on the location of the cooling of the lava, igneous rocks are classified as volcanic rocks cooling at the surface and plutonic rocks cooling in the crust. जब crust के अंदर ये कूल होते हैं तो इनको हम प्लूटोनिक रॉक्स कहते हैं या एक्सट्रूसिव रॉक्स कहते हैं, और जब ये सरफेस के ऊपर कूल होते हैं तो उसको हम वॉल्केनिक रॉक्स या इंट्रूसिव रॉक्स कहते हैं. क्लियर? सो the lava that cools within the crustal portion assumes different forms, and these forms are called intrusive forms. So some forms are here, and we will talk about these with the diagram also. Now you can see here, this is the diagram of different type of the intrusive forms. First we will talk about the batholiths. Now you can see the first layer is batholith layer in the bottom. So a large body of magmatic material that cools in the deeper depth of the crust develops in the form of large domes. So they appear on the surface only after the denudational processes remove the overlying materials, and they cover large areas and at times assume depth that may be several kilometers. So these are granitic bodies, and batholiths are the cool portion of magma chambers. Okay, now come to the next form, which is laccoliths. Laccoliths, you can see it is here only. See, this is a laccolith. This is a laccolith, and this is a batholith layer. Okay, so these are large dome shaped. You can see in the picture also, it is in a dome shaped layer. So these are the large dome shaped intrusive bodies with a level base and connected by a pipe like conduit from below. Now you can see in the picture, it is like a pipe and it is like a dome. So it resembles the surface volcanic domes of composite volcano. Clear? And only these are located at deeper depths. It can be regarded as the localized source of lava that finds its way to the surface. If we will take the example in India, the Karnataka plateau is spotted with domal hills of granite rocks, and most of these now exfoliated and are example of laccoliths or batholiths. Okay, now come to the next. Next is lapolith, phacolith and sills. So as and when the lava moves upwards, a portion of the same may tend to move in a horizontal direction, so wherever it finds a weak plane. So it may get rested in different forms. In case it develops into a saucer shape, concave to the sky body, it is called lapolith. Now you can see in this picture lapolith. There is no picture of lapolith, but you can just a minute. Sorry, there is no picture of lapolith, but you can imagine it is like a saucer shape or the sky body. You can see in this picture. Again, you can see saucer shape or the sky shaped body shaped, okay, or the concave to the sky body, you can say that. So it is the example of lapolith. And a wavy mass of intrusive rocks at times is found at the base of synclines or at the top of anticline in folded igneous country. So such wavy materials have a definite conduit to source beneath in the form of magma chambers. So these are called the phacolith. So वेवी जो दिख रहा है आपको थोड़ा सा वेवी, यहाँ पे कंपोजिट वॉल्केनो आ गया. थोड़ा सा अगर आप इसको वेवी देखते हैं, जिस तरह से ये है वेवी है, यहाँ पे लैकोलिथ है और उसके ऊपर थोड़ा सा वेवी पोर्शन देखते हैं. तो these are the forms of phacolith. And come to the next, which is dikes. Oh sorry, sill is remaining. The near horizontal bodies of the intrusive igneous rocks are called sill or sheet, and depending on the thickness of the material. So the thinner ones are called sheets, while the thick horizontal deposits are called sills. जो पतली sheets रहती हैं उसको हम sheets कहते हैं, और जो थोड़ा सा thick horizontal deposits हैं उसको हम sills कहते हैं. Clear? And another one is dikes. So when the lava makes its way through cracks and the fissures developed in the land, it solidifies almost perpendicular to the ground. So it gets cooled in the same position to develop a wall-like structure. So such structures are called dikes. Now you can see the picture of dikes also here. This is a picture of dikes. This is a sill, and this is a shock. This is a batholith, and lava flows. It is a volcanic dome, ash cone with a volcanic dome. And this is a cinder cone. These are the types of the volcanoes. Composite volcano, and this is a caldera with cinder cone on floor. Okay, now you can see this is a lava plateau. So these are the forms of some intrusive volcanoes. So now come to the dikes again. So these are the most commonly found intrusive forms in the western Maharashtra area, because we are taking the examples of India only. So these are considered the feeders for the eruptions that led to the development of Deccan traps. So here we already discussed all these things. So if you have any query or doubt, then you can put a message in the message box, or I am sending some question answers of this chapter also. So please do these question answers in your notebook, and if you have doubt or query, then you can tell me. So this chapter is completed now, and after this chapter I'll meet you with another video of chapter 5, minerals and rocks. Okay, so till then, take care and bye bye.